Thanks for coming. As Alan said, my name's Charles. I'm from Adobe. Actually, let me just skip right ahead to my intro. So yeah, I'm here to talk about JavaScript Puzzlers. I work for Adobe. I work with the identity team in Seattle. I'm actually from Vancouver, but I work out of the Seattle site. So I'm up often enough, and so here I am. I have 3 points of contact here, my website, my Twitter, and my GitHub, so feel free to reach out to me through any of these. So what are we going to talk about today? Puzzlers. So I have about 4 lined up. I'll explain what a puzzler is, but I have about 4 lined up, and if we have time, maybe 1 or 2 more, but hopefully we'll get through these 4. The talk will also be covering pure JavaScript. So we'll be talking about only JavaScript, meaning no external libraries, no third-party libraries or frameworks, which leads me to my next point. What are we not going to be talking about? So like I said, we're not going to be talking about any third-party libraries or frameworks, no Node, no Backbone, nothing like that. We are also not going to talk about any bugs. So these puzzlers that I'm talking about are going to exhibit behaviors as specified by the language, so no implementation-specific bugs. What is a puzzler? In short, a puzzler is just a simple program that demonstrates or exploits weird or quirky behavior in a given programming language, in this case JavaScript. So put simply, it's going to be a short program, anywhere from 2 to 15 lines of code. You should be able to read it quickly, and it's going to show you some interesting behavior of JavaScript. The format, so how is this going to work? So there's 5 steps here that I've kind of set out for this. First, I'll introduce the code. Like I said, it's going to be pretty short, anywhere from 2 to 15 lines. Then I'm going to pose a question, a multiple choice question, and you guys guess what the program does, essentially. Think hard though, because they're not always intuitive. Then I'll give a walkthrough of a reasonable explanation of the puzzler. That's to say, I'll give a naive walkthrough, meaning that I'll give a walkthrough of someone who doesn't know the puzzler. Fourth, I'll give you the real answer, and it might surprise you. And finally, I'll give a moral. So how can you avoid making mistakes like these in your own code? So let's begin. Actually, quick survey here. How many people are primarily front-end developers? A lot of people. How about back-end developers? Oh, it's about half and half. Okay. How many people work purely with JavaScript, like day in and day out? Okay, that's quite a bit. All right, well, here we go. So our first puzzler, I call this Maximus the Confused. So hopefully everyone can see this, but it's just 2 lines. I'll give you guys a couple, like a minute or 2, just to figure it out, just to read it. So the question, I'll just give the question now, is what does this print? So I'll mention, you feel free to talk to your neighbors and discuss this and stuff. I'll take a vote for who thinks what answers what. So I'll give you guys a minute or 2. So let's take a vote. You guys come up with an answer? Raise your hands if you think it's A. Two people? B? About equal. C? About equal as well. D? Or E? It's the bulk of people. Okay. All right. So let me give my naive walkthrough. I see that we have a variable called Commodus's rule, and it's initialized to the string literal thumbs up. Then I have an alert statement, and inside I have Maximus D plus, and then a ternary statement, Commodus's rule, strict equals thumbs up. If that's true, gladiator, else merciful. So I think Commodus's rule does equal thumbs up, so that's going to equate to true. So gladiator should get return, and so Maximus D will be concatenated with gladiator. So my answer is Maximus the gladiator, A. So let's see if I'm right. So it's E, none of the above. So most of you guys had this. It prints only gladiator. So why is that? Well, put simply, order of operations. Order of operations dictates that the plus operator takes precedence over the conditional question mark operator. So let's take a look at what the contents of the alert. And so knowing this now, within the braces, Commodus's rule, triple equals thumbs up, that's going to equate to true. But since the plus operator has precedence, it will actually concatenate Maximus D with the true instead of evaluating the ternary operator. So that actually turns into this. And then Maximus D true becomes the equivalent statement, and that's obviously not false because it's not null, and so it returns gladiator. So according to the MDN, the plus operator has precedence of a 6, while the conditional ternary operator has a precedence of 15. So not only is the ternary operator low, it's actually below most of the very common operators. So if you're using the ternary operator, you need to be aware of this. It's below the multiplication, mod, greater than, equal than, equality, even bit shift. So how do we fix this?
Use a lot of brackets.
So essentially, those brackets around Commodus's the equivalent statement, or sorry, the strict equals, it's redundant. That's already going to be evaluated first. What we want to do is put the brackets around the ternary operator. That's it. So the moral of the story: be aware of your order of operations. They matter. Be explicit. Place parentheses. There's nothing wrong with placing too many. Correctness is obviously more important than readability. So that's the first puzzler. On to the next one. So that was a good warm-up puzzler. Let's go to the next one. I call this block party. So I'll let you read that for a second. And the question is, what does this print? So I'll let you guys discuss again and we'll take another vote.
Really? I didn't realize. It's not rapid. It's not a function. Getting creative and call it never sign. It's not.
All right, you guys ready to vote? So raise your hand if you think it's A. Few takers. B? Okay, a lot of people. C? Handful. D? E? F? Less and less. G? Okay, handful of people. So let me give my naive walkthrough. So we have a variable called name, and it's declared in the global namespace. Then we have a self-invoking function, and inside of it we have an if-else statement. The if statement is checking to see if name is undefined. If it's undefined, then it's going to declare a variable name, initialize it to the string Mr. Bond, and alert goodbye plus the name variable Mr. Bond. But if it is defined, then it's just going to alert hello plus name. And since name is a global, and I see it right there, it should drop into this else statement and print hello world. So my answer is A, hello world.
So that can't be right.
So let's see what the answer is. Goodbye, Mr. Bond. So we had a lot of right people here. That's good. So why is this? So there are really two reasons why this happens. One is there's no block scope in JavaScript. So if you come from a Java or a C++ background, you're familiar with block scope. Something like this, you would see the variable I, and you would know that the scope is limited to within those brackets, those parentheses. But since there's no block scope in JavaScript, I actually exists there. The second reason for that behavior is a procedure called hoisting. So who here is familiar with hoisting? A lot of people. Cool. So again, if you come from a Java or C++ background, there's no hoisting. So that variable I will be restricted to within the brackets. But because of hoisting, I actually exist there too. And so what does the interpreter do? What happens there behind the scenes? Well, what hoisting does is it takes any variable declarations and it moves the declaration to the top of the function. But it keeps the assignment where it is. So it would essentially look like this. So knowing that, see what happened is it moved the variable I to the top of the function, but kept the assignment right where it was. And so what's that value of I? Well, that value of I at the alert is undefined. Applying that same logic to the puzzler, it becomes easy to see how we get the answer that we saw. This is what happens after hoisting. So that variable within the if statement gets hoisted, the declaration gets hoisted, yet the assignment remains where it is. And so at the top of the if statement, right when the if statement gets executed, name is declared and it now shadows the global variable, but name is now undefined. And so that's going to drop to the, into the if statement, declare a variable, or reassign it to Mr. Bond, and then alert goodbye Mr. Bond.
Question?
Yeah.
In your original, you defined var name equals Mr. Bond in the if statement. If you hadn't used var there, would it do the same thing?
No, it wouldn't have, because it would have reassigned, no hoisting would have taken place then, essentially. It would have reassigned the global variable. So that's a good point to make. Yeah, it's a good question. So, like I said here, the declaration got moved up and the assignment remained there. So now we can easily see why name is undefined. So, well, how do we fix it? A good convention to follow is, if you're going to declare a variable, declare it at the top of your function so there are no surprises. You won't get surprised by anything that the interpreter does. The moral: there is no block level scoping in JavaScript. Furthermore, there's a procedure called hoisting that will move around your declarations. So declare all of your variables at the top of your function so you don't get surprised by anything that the interpreter does. All right, on to the next puzzler. I call this loop-de-loop. So the question's right up there. So what does this print? There are two things I should point out here to help with the puzzler. One is that number isn't just any random number. That specifically is 2 to the 53. So the second thing to notice is this is a special for loop. Traditionally, you'd have I equals start, I less than end, I plus plus. But notice this is I less than equals end. So that will affect your count. So I'll let you discuss. All right, we ready to vote? So who thinks it's A? A few people. B? A few people as well. C? Only a few people. D? E? F? Oh, there we go. Most of the people say F. So let me give my naive walkthrough. So we have n, which equals 2 to the 53. Start is n minus 100. Then we have a variable count, which is initialized to 0. And we're going to iterate from I, which is start, to n, which should be 100 more. But we're going to do I less than equals n, so we should iterate through this loop 101 times. So I think count is going to increment 101 times, so we're going to alert C, 101. Let's see if I'm right. So the answer is F, none of the above. So it looks like most people got that. So it enters an infinite loop. So the question is, why does it enter an infinite loop? So like I said before, this number is a special number. It's 2 to the 53. Why is it special? Well, first we need to know how JavaScript represents numbers. So JavaScript uses or abides by the IEEE standard for floating point arithmetic, the IEEE 754 spec. So this is actually the same specification, for anyone that's aware, it's the same specification as the Java double. This essentially means that all numbers in JavaScript can be represented in this format. So here's the number we want to represent, and it can be represented essentially by a mantissa multiplied by an exponent. So if you remember your representation classes, that's how numbers are represented in the IEEE 754 spec. How that looks in binary is this. So we have 64 bits, we have 1 sign bit, 10 bits for the exponent, and 53 bits for the mantissa. So what does that mean? It essentially means that 53 bits are the maximum number of bits that you can use to represent integers. In short, 2 to the 53 is the largest exact integral value that can be represented in JavaScript. Anything beyond that goes into the hazy area of approximation. And so you can essentially lose precision, you will lose precision beyond this value. So from the ECMA spec, all the positive and negative integers whose magnitude is no greater than 2 to the 53 are representable in the number type in JavaScript. What does this mean in terms of, I'll give you a concrete example here. We have num A, it equals 2 to the 53. Num B equals num A plus 1. Num A strict equals num B is true. Now why is that? It's because num A is 2 to the 53. We add 1, and immediately we lose that precision. It rounds back down to 2 to the 53. And so this will perpetually stay as 2 to the 53. So applying that logic to this puzzler, it's easy to see how we get the behavior. So we initialize start to 2 to the 53 minus 100. We count up 100 times and we get to 2 to the 53. And when we try and go above it and add 1, it adds 1, then immediately loses that precision. It rounds back down, and it never exits this for loop. And so this will count forever. So how do we fix it? Well, don't use 2 to 53. So I mean, it's obviously a convoluted example just to illustrate the puzzler, but the real moral is be aware of your number representations and ranges because they impose real limitations on your programs. So especially when you're working with important numbers like money, you would want to make sure that you don't lose precision there. All right, and time for my fourth puzzler. I call this, let's print some zip codes. Okay? So I'll let you read that for a bit. So the question is, what does this print? So I'll let you decide and we'll take a vote. All right. So, raise your hand if you think it's A. So a handful of people. B? C? That's most of the room. Okay. D? A few people. E? A couple guys. F? Cool. A few people there too. Okay. So let me give my naive walkthrough here. All right. So we have a variable, zip codes, which is initialized to an array of 5 strings. Each of the strings are a number, a 5-digit number. Then we have a for loop, and it's going to iterate through each of the values of the array, and it's going to send it to this sanity check here. So this sanity check does 2 things, it looks like. It calls parseInt and it checks that the result is a number, and then it calls parseInt and it checks that the result is greater than 0. So essentially checking, are each of these numbers greater than 0? If they are, then alert it. So 93021, I think that's, well, yeah, that's a number. It's greater than 0, so it's going to alert 93021. 02392, so it has a leading 0. I think parseInt will do the right thing, and I think parseInt will do the right thing and will strip that and will return 2392, which is a number and greater than 0. So I think it'll print 2392. Same with 20341, no surprises there. Again, a leading 0 in front of 08163. Again, I think it'll do the same thing and just print 8163. And finally, the same, no surprises for 32959. So my answer is B. All right. Let's see if I'm right. So the answer is It varies. So, how does it vary? Well, Firefox prints that, but Chrome prints this. So, okay, so why? Why is this? This really all comes down to the API, the parseInt API. So let's take a look at it. So parseInt will take two parameters, a string and a radix, and the spec says radix is optional. However, the puzzler comes into play because of that optional radix. So what happens when that radix is removed or omitted? If the input string begins with a 0x, or 0 capital X, the radix is assumed to be 16. It's assumed to be a hexadecimal number. If the input string begins with a leading 0, it is treated as octal or decimal. Yes. And if the input begins with any other value, radix of 10 is assumed. So obviously the key point is the middle one. If it's a leading 0, it's either treated as octal or decimal. So again, from the MDN, Mozilla had this to say. Exactly which radix is chosen is implementation dependent. For this reason, always specify a radix when using parseInt. So it's interesting they say that, but then they explicitly mention that radix is optional in their API. So anyways, yes. So another important note about parseInt, if parseInt encounters a character that isn't a numeral value, it will stop right there. The point of that being, if you go parseInt string 14 cars, it will return 14, right? So good intentions, but it can be easily abused. It can be easily misused. So a closer look. So this is Firefox, latest version of Firefox, or as of last month. 90321, no surprises, 02392. So Firefox treats this as octal. And so it's going to go 2 times 8, so 2 times 8 to the 1, 3 times 1, but 9 is not a valid octal digit. And so it stops there, and you get 19. So I didn't just make up 19, that's what happens. Again, no surprises for 20341, but when we get to 08163, it treats the number as octal again, but immediately sees an 8, which is invalid in octal, and it returns 0. So this does not print, because it's not greater than 0. And again, 32959 prints as expected. So how do we fix this? Well, let's follow what the MDN says, and let's always pass a radix. Simple fix, just always pass a radix. That's it. The moral, parseInt takes an optional radix, but really it's not optional. Omitting this will cause unpredictable behavior across the browser, so be explicit and just always include it. So that's my last puzzler. Any questions? Yeah.
You have some more of those?
I do. Do we have time? I can do a couple more. All right. Let's do it. Let's do it. Which one should I choose? Let's go for... Okay. I call this a case of mistaken identity. Okay? So, let you read that for a bit. I'll give the question now. The question is, what does this print? Alrighty. Ready to vote? So who thinks it was A? A few people. B? A few people. C? D? Most people, okay. E? F? A bunch of people. And G. Okay. So again, let me give my naive walkthrough. Okay, so we have a function, showCase, and it takes a value. And inside of this function, we have a switch statement. And it has 3 cases and a default, the strings A, B, and C. And then we call showCase with a new string of A. And I have a case for string A right there, so I think it's going to print case A was selected, so my answer is A. Let's see what the real answer is. So, don't know what happened. So most people got that right. So what happened there? So why did that happen? The reason is because the switch statement internally uses strict equality as opposed to the non-strict equality operator. What's the difference between the strict equality and the non-strict equality is that strict behaves exactly the same as non-strict, except no type conversion is done. So that's important. So essentially, when you're testing equality using strict equality, it checks 2 things. It checks first, are the types equal? Second, are the values equal? Oh, there we go. Most of you probably noticed that we invoke showCase with a new string object as opposed to a string literal. What does that mean? Well, this is what it means. The type of a string literal is string, but a type of a new string object is an object. So, obviously, if we're using strict equality to equate literal string A triple equals new string of A, it's going to check first thing, are the types equal? And it's going to barf right there. It's going to say, no, the types aren't even equal. Let's stop, and it's going to return false. And so it moves on to the cases, and if we look, again, apply that logic, it's going to move on to those cases for essentially all of these and drop right into the default. And it's going to say, don't know what happened. So how do we fix it? Don't use new string of A. Use string literals. Yeah, question.
Why don't you ever use new string?
So it's interesting. I've given this talk a couple of times, and I get that question every time. And from what I understand, it's because JavaScript, when it was first designed, and so I can't really speak to the language implementers or the designers, but this is what I've heard. When JavaScript was designed, the notion was to make it as simple for Java developers to port over, hence the name JavaScript. And so they moved over conventions like new string. Any other questions?
Cool. Awesome.
Cool. Thanks, guys.
So that's the first time we've ever had someone ask for an encore, and you actually had.
Thanks, guys.